Stanford University.
Okay, well, welcome then to Stanford CS 193P. This is developing applications for iOS. Hopefully you're in the right place. This is fall quarter of 2017. And I'm going to breeze through a few slides here, and then I'm going to sit down and do a nice involved demo just to show you what it's like developing apps for iOS. That's the best way to learn, is for me to show you how to do it. Okay, so this is what I'm going to talk about briefly first. So what are you going to learn in this course? Of course, you're going to learn to build cool apps. iOS apps are cool. Why are they cool? Well, they're cool because they live in your pocket. You can show them your friends. It's right there. Also, incredibly easy to sell and market your apps online because you have the App Store, and there's a very vibrant community. That's because Apple's always doing cool new things like virtual reality and machine learning and all these things, and there are millions of apps on the App Store, so there's a lot of people doing this stuff. But you're also going to learn in this class a little bit of real-life object-oriented programming, okay? You all are taking classes, networking and databases and graphics, your other CS classes. And here we're going to do all those things in a real-life platform, okay? Because over the weeks we are going to do all of those computer science-y things for real, okay? And especially object-oriented programming, because iOS is completely and utterly object-oriented. You cannot develop for iOS without being a serious object-oriented programmer. And that brings me to my prerequisites for this course, which is object-oriented programming. You have to be comfortable with object-oriented programming. Definitely CS 106A and B, and hopefully CS 108, which is object-oriented programming here at Stanford. And the other thing you got to be comfortable with is writing a lot of code. Okay, this is all your homework in this class. There's a little bit of reading the first few weeks about the language that we're going to develop in, but mostly it's just programming, and more programming. So if you're not comfortable writing a lot of code, then this class, you might want to wait until you've taken some other classes that ask you to write a lot of code before you dive in here, okay? So what's in iOS? What am I going to be teaching you? Okay, I've divided it here into 4 layers. The bottom layer is near the hardware, and the top layer is near the user, okay? So at that bottom layer, you might be surprised to find out that iOS is Unix, okay? It's a BSD variant of Unix, and so all of the stuff that's going on down there is all happening in C, basically, right? Unix is mostly written in C. Most of that stuff is in C. I'm not going to teach you anything at this layer, okay? This is an object-oriented class. Everything we do will be object-oriented. You will not see me teaching you anything down there, all right? The next layer up is called the core services layer. This is an object-oriented layer on top of those lower services, okay? This I will be teaching you. Okay? So if we want to do things like find out where the phone is on the planet, or find out its orientation, or access some files in the file system, we're going to be using this layer right here, and I'll be teaching you all about this layer, okay? Core services layer. The next layer up, this is kind of not a strict layering, but is the media layer. Now, don't forget that your iPhone is essentially, originally, an iPod with a phone in it, okay? So it's got all kinds of media, video, audio of many different kinds, images, all this stuff. And unfortunately, this is a layer I'd love to teach you, but I have to cut something, so I'm not going to talk much about this layer, unfortunately. Okay? So I know some of you might be wanting to write a cool game that has 3D sound with TIE fighters ripping around from the back into the front. And that's all possible and quite straightforward to do, but in 10 weeks I have to pick what I'm going to teach you. And so I'm going to focus on core services, and then this layer, which is Cocoa Touch. So Cocoa Touch is the UI layer of iOS. This is where the buttons and the sliders, all those things are. And there's also really powerful objects here, like the map kit has a single object that you can just drop in your app that gives you pretty much the entire functionality of the Maps app inside a rectangle inside your window. Okay? So you're talking about a wide variety of UI stuff here, and I'm going to try and cover as much of this as I can. Okay? So that's what you're going to learn in this class. The platform we're going to develop on is Xcode 9. So you're all going to need to download Xcode 9. It's free. And it only runs on your Mac. And there's this other little app, Instruments, but it's really kind of just an add-on to Xcode 9. We're going to do everything in Xcode 9. Source code editing, debugging, all that stuff is going to happen in Xcode 9. You're also going to have to learn a new language, okay? iOS has 2 languages you can develop in, Objective-C and Swift. Swift is the newer one. That's the one I'm going to teach you. Everything you learn, though, in Swift, all about iOS, will apply if you later want to go learn Objective-C and work for a company that is still writing in Objective-C, which is a perfectly valid language to write in. But Swift, kind of a cool new language. I think you're really, really going to like it. If you're a serious computer scientist, another language is like big yawn, whatever. Just tell me what the syntax is, tell me what the key fundamental mechanisms for designing with it are, and I'll learn it. So if you don't have that attitude towards languages, you're going to be kind of having trouble out in the real world being a programmer. And then, of course, there's millions of what we call frameworks in iOS. Frameworks are just collections of objects. Like the biggest one is UI Kit. That's where buttons and sliders and all that stuff is. Foundation is another big one. That's where a lot of that core services stuff I was talking about is. But there's the Map Kit, Core Motion, Core Data, Object-Oriented Database, all kinds of them. And I'll try and get to them, as many of them as I can. And last, but definitely not least, there is a design strategy for building iOS apps that you have to use. Okay, this is not like an optional, here's a good idea, why don't you design this way? You must design this way, okay? It's called MVC, Model View Controller. How many people have some experience doing MVC in any other? Okay, it's not so many this quarter. Usually I get half the people, but I'll be teaching you all about MVC. The start of the lecture on Wednesday is going to be a full coverage of MVC, what it is, how it works, all that stuff. All right? So now I'm going to dive right into a big demo. That's the best way to learn how to do iOS development is with a demo, seeing it happen. We're going to build an application from scratch. This slide right here is a slide for you to look at later and see, did I learn all these things? Because I should have learned them today. Okay, this is not a slide to read now. Okay. Since I'm not going to get back to the slides, let me just say what's coming up real quick. You are going to have a reading assignment that goes out today. It's basically starting to read the manual on Swift, so you can learn this new language. I'll spread it out over 3, maybe 4 weeks, so you don't have too much reading all at once. But those reading assignments are going to be in addition to programming assignments. The reading assignments go out on Monday, they come back on Monday, they're due the next Monday, and then the programming assignments go out on Wednesday, and they're due the next Wednesday, generally. Okay, at least we'll start the quarter that way. On Friday, we have an optional section. It means optional in that you don't have to go there. The topics we're going to cover are kind of additional, but this Friday's one is a big one. It's tips and tricks of Xcode, including how to use the debugger. So if you've never used the debugger in Xcode, this is a good one to go to so you can see how to use the debugger for your program. If not, you know, it's a debugger. If you used other debuggers, you could probably figure it out. But anyway, it says right there that it's in Hewlett 205, but I don't think there's such a room. I think it might be in Hewlett 105. I don't know. Watch Piazza and we'll tell you where it is. But it is going to be 11:30 to 12:20. And so next week we'll talk more about Swift and then launch into all of iOS. All right, so let's jump right into the demo here. And I apologize in advance for going fast on this demo because there's a lot to cover, and you're going to find that in this course in general. I tend to go pretty quick because I want to teach you as much of this stuff as I possibly can. All right, Xcode. Here's Xcode. I went to the Mac App Store, I searched Xcode, I found it, I downloaded it, it was free. It doesn't cost me a dime to develop for iOS. When you launch Xcode for the first time, you're going to get this thing right here. So we need to build an app. Now, I decided to show you the app that I'm going to build here in real life. Okay, so you see these cards that I've very artfully taped up here. These cards are going to let me play a game called Concentration. How many people have heard of the game Concentration? Not too many. Okay, so Concentration is just a card game. Behind these cards that are all face down, there are some pictures. And the goal is for you to match the pictures up. So there's 12 cards, 6 pairs of pictures. So I get to pick 2 cards at a time, and if they match, I win, and the cards go away. If they don't match, I have to turn them back down and pick 2 other cards. And it's called concentration because I have to concentrate on the ones that didn't match so that later I can go back and match them. So let's just flip some cards over here. I'm going to start with this one right here. I really don't know what's behind these, but let's see. Okay, this one is a pair of purple bats. Okay, so now I'm trying to find another pair of purple bats. Let's try right here. I found them right away. Okay, so this is a match. I get some points. These come off the board. Okay, so now I'm searching for more matches. All right, let's try this one right here. It's a ghost. Okay, I got the ghost right there. Let's try this one. Oh no, no match. That looks like a Rorschach thing, but it's a witch, turns out. That looks like a witch on her broom, if you can see right there. So I don't get any points for this, and I have to turn these back down and pick 2 other cards, all right? So I'll turn these down. Hopefully you guys are concentrating and you can remember what these things are. I'm going to try this one. Ooh, it's a cat. Kind of a cute cat right there. And let's pick another one. How about this one? A pumpkin. Okay, well, in some ways this is bad because we have another non-match, but it's kind of good in that supposedly if we're concentrating, we know where 4 cards are. Okay, so turn these back down, pick 2 new ones, and I'm going to pick cards that I haven't seen before because I already know where these cards are. All right, that doesn't fall down. All right, how about this one? This one is, oh, the witch, the witch. Okay, so now if I was concentrating, I remember where the witch was. Now, where was it? Was it this one? Yeah. Witch, yes, okay, so we match these and these come off the board, okay? And this just continues, and obviously the fewer things you choose, okay, the fewer times that you pick, like here's a cat, where's that cat? I think it's down here. Oh no, that's not a cat. Okay, now this kind of mismatch I should probably get a big penalty for because the cat I've seen before, it's right here. So I should have matched it, and I didn't, I wasn't concentrating, okay? So this is the game we're gonna build an app to do. All right, make sense? Simple game. All right, back to Xcode right here. Now this Xcode portal, the splash screen that pops up here, it has all the apps that you've been working on all quarter right here, and then it lets you create a new app over here where it says create a new Xcode project. So we're going to create a new Xcode project. I just click that button. When you create a project, it asks you, well, what kind of project do you want to build? And we want to build an iOS app. You see up here at the top, we could build a watch app or an Apple TV app, but we're building an iOS app. And this is saying, what kind of iOS app would you like? So here's a game, augmented reality. We're always going to pick this one on the left, in the upper left corner, single view app, because it's the simplest starting template. And I want to teach you how to write the code to do all those other ones. I don't want you just click a template and it just shows you, the infrastructure for a game or whatever. I want to show you how to do that. So we're always going to pick a single view app. When we pick the kind of app we want, it's going to ask us some questions like, what do you want to call this app? Well, this game is called Concentration, so I'm going to say Concentration. The next one down here is Team. That's the development team working on it. That's you. Okay? Now, when you run it, it's going to say Add Team or Make Team right there. To me, it knows it's me. And when you do that, all you're going to need to create a development team is an Apple ID. You don't have to pay any money. Any Apple ID will do. Go through the process. You'll create a development team. Okay? Next is this organization name. That can be anything you want. It just shows up in the copyright in your Swift files. All right? But this one, very important that this be uniquely identifying you. Okay, so a real easy way to do that if you're a Stanford student is edu.stanford.cs193p.your SUNet ID. Instead of lecture there, put your SUNet ID. That's clearly going to identify you, right? If you're not a Stanford student, you have to figure it out on your own. And then the language, I told you about the 2 languages. We're going to do all our development in Swift. You can mix Swift and Objective-C even in the same application. They're very interoperable. Swift was designed fully with Objective-C in mind, so it's not a problem. So we'll always pick Swift here. And we're not going to do any of these things down here in the first 2 weeks, but we will eventually get it object-oriented databases and testing. We'll eventually do that stuff. So I'm going to click Next. Now it's asking me, where do you want to store your project? I strongly recommend you put it in your home directory in a folder called Developer. That's the kind of the canonical place that people put their projects. So all your projects will collect here, okay? Concentration, and then the other ones we're going to do later in the quarter. This source control, we'll talk about that later in the quarter as well, but we're not doing that for the first week. Okay, here it is, your first iOS app. Now, what we're seeing in the middle of Xcode, right? How many people have done something in Xcode before? Okay, so about half of you, so that's pretty common. So you know that in Xcode, this middle area is your main editor. And we're seeing right now in this main area is our project settings, right? We answered some of these in those previous little things that came up. And the reason it's showing our project settings is because on the left here in this blue area, we have the project selected. See the dark blue selection at the top? That's the project selected. And this whole blue area on the left is called the navigator. And the navigator lets you navigate through your project. In this particular tab, it's showing me the files in my project. I have 6 files right here. They were given to me when I chose that template, the single target, single view template. But I can also navigate by searching right here. If I'm debugging, I can navigate through my breakpoints, etc. So you'll get real familiar with using this blue thing right here, and you can say how much space you want it to have to navigate through your application. Now on the right-hand side, this over here, you can actually see a little area that has a top and a bottom, okay? This is called the Utilities pane, and I'm going to show you all about that in 5 minutes, so I'm going to hide it right now. You see this button in the very upper right? That hides that, and this one hides the navigator, okay? So if you want to give more space to your main window, you can do that. There's another button here, you see that one? That hides your debugger and console window. So this is the debugger right here, okay, where you're looking things going on in your debugger, and this is the console. Now, the console is just a place where there's a function in Swift where we can print text out there. It's really great for lightweight debugging. We're just printing out what's going on inside my app, and that's what I'm going to do today. I'm not going to show you the debugger today. That's for Friday. I'm just going to show you using print to debug, and you can also move this up and down as high as you want. So it's very nice to be able to kind of organize your space. Like I have a fairly low resolution screen here, so I'm going to be trying to hide things as much as possible to make the text really big so you can see what I'm doing. All right, one last thing I want to show before we dive in here is this area up here. You see this? This is how you run your application. Okay? So when you run your application, you have to decide where are you going to run it. Now you can run it on a device, so you can hook up a device to your Mac, and you can hook it up wirelessly, actually, or with a little USB cable or whatever. And I don't have any hooked up, so I can't do that. But I can also run on all of these simulators. So these simulators simulate this various device, like an iPad or an iPhone 8 Plus or whatever. And you can run your app on any of these that you want. And in fact, the simulator will open multiple of these at a time if you want. So I'm going to do the latest and greatest here, which is the iPhone 10. Okay, I'm going to run my app on the iPhone 10. And let's go ahead and run it. We haven't done anything, so it's just a blank app, but let's just run it for fun. You see this play button right here? That's how you run. So I'm going to click that play button. Now it is compiling my app, as you can see at the top. It's building it into a binary. It's loading it onto the device, or in this case, a simulator, and it runs it. Okay, so here it is. It looks like an iPhone 10, right? And it's running my app, and it's completely blank. Well, because I haven't done anything. I haven't built any UI. But if I press the home button on the iPhone 10, everyone know how that works? You slide up from the bottom. Sliding up from the bottom is like the home button, because there is no home button on the iPhone 10. And you can see there's our app, concentration right there. But all other apps are there too. Settings, right? You can go into the settings app. And if you want, you might have your app needs to set some setting, like, I don't know, text size or something like that. So these simulators are truly simulating the device. They're not just running your app only. Okay? So that's kind of cool. And we can also go back to our app. Just go back here and say concentration. Here's concentration. All right, so now we're familiar with Xcode and kind of all its pieces right here. Let's take a look at the files that were created for us. Now, there's 6 files, but actually we're only going to look at 2 of them. Okay? For example, this one, assets right here, that's your images, including your app icon, which we haven't set. I don't really need that. Your launch screen right here, I'm selecting that as well. This app delegate up here, we don't need to touch any of these to make our concentration app. So I'm selecting them all, and I'm going to right-click on them and go down to New Group from Selection and put them in a group. I'm going to call that group Supporting Files, because that's what they are. They're supporting files. By the way, I would not put your info.p list in your supporting files. Leave that at the top level. Seems to be better. So this other file here, viewcontroller.swift, is just some Swift code. We'll get to that in a second. And right here, main.storyboard, that's your UI. Okay? Now you're going to build your UI in Xcode graphically. Okay? You're not going to code it up. You're going to do it graphically. And not only that, the way you're going to build it, you're going to drag out buttons and text fields and sliders and things like that. And it's going to actually put real buttons and real sliders live on the screen at the time. And you're going to edit them and set them up the way you want. And then when you run them on your app, it kind of freeze dries them, brings them over, and adds water, and they come back to life, and then they run. So when you run, it's not like you don't click a button here and it generates a lot of code to put those buttons there. It's actually editing these buttons live. Okay? Now, notice that I got this sort of iPhone-shaped rectangle. Can you all see that? Yeah, it looks pretty good. This iPhone-shaped rectangle is where I'm going to edit my UI. And in particular, this is an iPhone 8-sized rectangle. You see that? It says View as iPhone 8 down here. I can click on this and actually look at other iOS devices. Okay, so I can look at my UI, how it would look, let's say, on an iPad. Now, the iPad is huge, so maybe I want to zoom down a little bit to see it better. I can also look at it in landscape mode. Okay, so here's portrait and landscape of an iPad, for example. I could go to a different kind of iPhone, like here's my iPhone 10. All right, so I can look at all possible iOS devices and see how my UI looks. Now, our goal, eventually, once we learn enough about iOS, is to build UIs that look good, even if they're in landscape or portrait, iPad, iPhone 8, iPhone 8 Plus, which is big, iPhone 10, it doesn't matter, okay? That's our goal. Now, in the first week, I can't teach you any of that, so we're going to have our UI just try and look good on an iPhone 10. But next week, not to worry, we'll try to make it so it looks good on other iPhones as well. And your assignment, too, is going to really ask you to make an app that just looks good on all possible iOS devices. Now, on the left over here, when we brought up this area in Xcode, by the way, is called Interface Builder because we are building our user interface, so Interface Builder. This area over here is essentially all the things that are here, but in text form, like a text outline. And I'm going to hide that. You do that with this little button down here. See it says Hide Document Outline. I'm going to click that to hide that. We'll go ahead and hide this phone chooser as well. And we have our little UI here. We'll look at that document outline later in the quarter. All right, so I want to build my UI. How do I build a UI? Okay, I'm trying to build concentration here. So I'm going to need some cards. And I'm going to use a button to represent a card, which is kind of cool because you tap on a button and it does something. And that's good because when you tap on a button, I want it to flip over. Okay, I'm going to have my cards flip over. So that's the first thing to do. Let's build one card that will flip over when we click on it. All right, so I'm going to zoom in. By the way, you can hold down Alt. You see in the lower left, I have a thing here that shows what I'm pressing, Alt and Control and Command and all that stuff. If you hold down Alt and use your mouse wheel, you can zoom in and out on your UI, which is kind of cool. Otherwise, your mouse wheel moves it up and down, which is also kind of cool. All right, so we have our UI here. How do we put a button in this UI? Okay, as promised, we go over to this thing that had a top and a bottom called the Utilities pane. And we're going to look in the bottom to start, and specifically in this Object Library tab. And we're going to see a whole bunch of objects, remember, and I mean objects like in an object-oriented sense. This is all object-oriented. And all these objects like labels and buttons and text fields and switches, and even web views and table views and text views and even AR kit. Here's a little AR kit of augmented reality views. These things can all be dragged out, multi-touch gestures, dragged out to build your user interface. Okay? And I'm going to cover the vast majority of the stuff in this very large list right here. But we're going to start with a simple one, which is towards the top, which is button. So I just want to drag a button into my UI, and I just drag it in. I pick it up with the mouse and drop it in my UI. Now, when I move this around, look at these blue lines. See these blue lines? They're trying to help me put it like exactly in the middle, or exactly in the middle on the bottom edge, or up in the upper right corner. These blue lines are critical to building a UI that will work when you rotate or on a bigger device or whatever. But we're going to ignore the blue lines for now because I said I'm going to teach you that next week, all right? So here's my button. It's very, very small. I want it to be bigger. Well, I can just grab these handles on the edge here and resize it to whatever size that I want. Maybe make it a little more card-shaped or something like that. And I can also edit the text on here by double-clicking on this, right? I don't want button. Maybe let's do the back of the card. Let's see what the back of the card looks like. So I'm just going to delete it. So now my button has no text on it, right, which is fine. How about setting the background color to orange? These cards are orange in our Halloween theme here. They have orange backgrounds. How do I do that? Well, that's the top of this Utilities pane. Notice that when I select a button, I get this UI over here that is specific to setting the attributes of a button. And not only that, it's object-oriented. So I have the button stuff here, and as I scroll down, look, I get UI for control because button inherits from control. And then control inherits from view. So I get UI to edit a view because a button is a view, right? It inherits from view in an object-oriented sense. So the background of any view is settable here in this UI. It's right here under View. It says Background. Right now the background is clear. That little line through a thing means clear. So there is no background, so it's showing the white from behind is showing through. But I can easily change this to orange by just clicking there and going down here. You know, there's a lot of preset colors here. I can go to Other and pick it by name. I could pick orange. I could go pick a crayon that looks orange, color wheel, whatever. But here I want orange, so I'll just pick it by name. And now I've set the background of my card to be orange. So that's good. That's looking pretty much exactly like this. I'm happy with it so far. And in our Halloween theme, to make it even scarier, let's make the background here be black, okay? So I'm going to change this to be black. And the way I do that is I just click on it, and now this right-hand side doesn't say button at the top, it says view, because this big space is just a blank view. It's not a button view or anything, it's just a view. But it's got this background thing, same way. So I click on it, and here I'll just pick it from this list of predefined things, black color. And now I have a nice orange on black UI, okay? Looking pretty cool. Now what about when the cards are face up? Well, when they're face up, they're white, and then they have an image on them. Now, I could have the cat or the spider web here or whatever be some JPEG image or something, but I got a really cool idea to make this really easy. Let's make it be an emoji, okay? Because if we just put an emoji in here, then we have a lot of choices, and it's really easy. We don't have to go find the images or anything like that. So that's what we're going to do. So I'm going to make this look like the front of the card. So I'm going to go down here and change this orange back to white. Okay, it's white color. And I'm going to put on here, instead of blank, I'm going to put an emoji. Now, most Mac apps, if you go to their edit menu, at the bottom of it, there's this emoji and symbols. I don't know how many of you know that. But if you go to emoji and symbols, you get this window right here that lets you choose all these various emoji. We got a Halloween theme here, so let's look for a ghost. Oh yeah, Mr. Ghost right there. Okay, so that's a good ghost. He looks like a fun ghost even. We'll double click right there to put him on the card, and there he is. He's very, very tiny. I could go zoom in and look at him, but he's even small compared to the size of the iPhone 10. If my user was doing this, they'd be like, what is that? Okay, just like a little smudge. So we want to make this much larger. So again, I'm going to the top side, top half of this utilities pane, and if I look down here, look, font. System font 15 point. So I'm going to make that way bigger. Let's make it 50 point. Okay, now we got a nice big ghost. Okay, awesome. We have got all we need in terms of design to do our UI. Let's go ahead and run and see what happens here. See if this black background and this ghost and all this stuff is showing up in our app when we run. And of course it will be. Here it is. And when I click on it, can you see that it's flashing a little bit there? That's saying, that's giving me a little feedback. Yeah, you touched on that. It's nice. But it doesn't do anything, right? And we want it to do something. Mainly, we want it to flip over. Okay? So let's go do that. How do we make it so something in the UI does something? Well, we're going to hook it up to some code. Specifically, we're going to hook it up to this Swift code right here. Now, they gave us these things right here, which I'm going to delete so as not to distract you. But this is your first look at Swift code. Let's look at it real quick, see what it does. Import, it's just like include. It's just bringing all of UIKit in for our use. UIKit is iOS's framework that has buttons and sliders and all that stuff. Okay? Kind of that top Cocoa Touch layer we were talking about. So this is the declaration of a class. In an object-oriented sense, a class. Of course, we use the keyword class. This is the name of the class. View controller, this is not a very good name. It's very generic. Probably this wants to be called concentration view controller or something like that. Do not change the name of this in your homework, okay? Changing the name of this requires a little more than just changing it right here because it's also showing up in your UI. So you have to change it in a way that changes it in both places. This is its superclass. Okay, this is object-oriented programming. We have inheritance. It's inheriting from UI view controller. That class, UI view controller, is in UIKit. You can tell because it starts with UI. And what that class does, it knows everything about controlling a UI like this. That's what it does. So by having our view controller inherit from that, it inherits all the capability to control that thing. So all we have to do is put the code that has to do with a concentration game in here. So that's great. Then inside this curly brace, we're going to put all our methods and instance variables. Who does not know what the word method or instance variable means? Okay, good, everybody does, and you should, because that's fundamental in object-oriented programming, right? So we're going to put all our instance variables and methods inside those curly braces. That's how we're going to declare our class. So how are we going to make this button do something here? Well, what we're going to do is we're going to create a method in here, and we're going to make it so that when you press this button, it calls that method, of course. How are we going to do that? To do that, believe it or not, we need to get this UI and this code over here on the screen at the same time. And we do that with this little button right here, this little circles thing right here. This is called the Assistant Editor. And when I click it, they come on screen, both of them on screen at the same time. And I can adjust this space however I want. Maybe we'll get rid of this now. All right, so here's my UI and my code on screen at the same time. Now, why do I want them on screen at the same time if I need to hook them up? Because the way I hook them up is I hold down the Control key and drag a line from the UI to my code. Okay, I know it's kind of weird, but that's how we do it. And when we let go of that drag line, it says, oh, you will make a connection between UI and code. No problem. What kind of connection would you like? You can make an action, with it, which is a method, or one of these two outlet things, which I'm going to talk about later in this lecture. So let's start with this action one. An action connection means when this button is pressed, call a method. And I get to say what the name of the method is. I'm going to call it touch card, because that's what's happening. Someone's touching on this card. And this method that's going to be created for me, it can have arguments. It could have no arguments. That's none. Or it could have one argument, which is the sender. In other words, the button that is sending me this. I really need that argument because when this touch card gets sent to me, I need to flip it over. So I have to talk to it. Okay, so I want that argument. And really important, pay attention right now if you're dozing right now, is that we do not, this is the type of the argument. See, it says type any, and we want that type to be button, okay? Because a button is sending this method to us. Now, I don't know why that doesn't default to button. I've been saying that for years. It should, but it doesn't. And if you don't change that from any to button, the rest of this code is not going to work. So definitely, if you remember nothing else from this, remember to change that. All right? So we have this button here, and I'm going to hit these other things. But, you know, here's obviously we were sending it to the view controller. The event touch up inside just means when you touch up inside the bounds of the button, send this message. All right? So let's connect. I'm going to hit connect. It's going to give me a method. This is your first look at a Swift method right here. And let's look at the parts of it. Interestingly, this is not part of a Swift method. Okay? This is just a special directive that Xcode is putting in there that causes it to put this little round circle here where the line numbers are. You see how line number lucky 13 there is a circle instead? Okay? If I mouse over that circle, I'm not clicking. Just mousing over, okay? If I mouse over that, it'll show me which buttons send this message. Okay, which ones invoke this method. So that's all this IB action does. It just causes this circle to appear right here. Now this is the syntax of a Swift method. So let's look at its parts. Func is just the keyword that says this is a function. A method is just a function on a class. It is legal to have functions outside of classes. They're global functions. We almost never do that because we're very object-oriented, but you can do it. This is the name of the method, touch card. I chose that in the little pop-up. This is a list of all its arguments. Okay? This method has one argument. The type of the argument comes at the end with a colon type, which is a UI button, obviously. Okay? We said we wanted one argument, which the sender was a UI button. That's what it is. This are the names of this parameter. Names plural. Now, there's two things about Swift that's going to be quite different from what you're used to in other languages. One, every argument has a name that you actually include when you call the method. Okay? So, like in Java, you would say touch card, open parentheses, 6, comma, hello, comma, 5. You would never do that in Swift. Each parameter would have a name in front of it. Okay? That way, if you're calling it and you're reading the code, you don't have to remember, oh, that first argument, what's that again? Because they're each named. And the other thing is it has two names. Okay? The two names are the external name, that's the name callers use, and the internal name. That's the name we're going to use inside of our implementation. Okay? Now, I'm going to write my own method in a second here, and we'll talk about this more, but that's what's going on here. Now, if this method had a return value, you show that by saying arrow int, let's say. That would mean this method returns an int. Okay? Very simple syntax for that. But this method doesn't return an int, but you could make it so it does. Okay, so let's make sure this is working. I'm just going to use that print function I was talking about. This is a global function called print. It just takes a string and prints it on the console. So here I'll print ag, a ghost. Okay, and we're going to run our app and see if this is working when we press the ghost. Okay, so by the way, when we are going to print stuff on the console, we probably want to bring this up from the bottom so that we can see our console. We can make our debugger smaller. Here's our console. Bring it up. There's actually a cool thing you can do. I'll show you an Xcode tip. If you go here to Xcode behaviors and edit behaviors, okay, and you go down, you can have it so that Xcode does things, opens windows, does other stuff when certain things happen. For example, if you're running and it generates some output on the console, well, you can say, show the debugger. Okay, and it'll automatically bring that thing up from the bottom if it's not there. So that's kind of a nice little feature. All right, so let's run it. Those are the kind of tips and tricks we'll cover on Friday, by the way. Good reason to go on Friday. Question, yeah?
Can you go over again how you link the button to the view controller?
Yeah, how we connected the button to the view controller? Yeah, I'll show you that in just a second. So let's make sure it's working, and then I'll show you how we connected it again. So we have this button here. I'm going to click the ghost and look down in our console. Look, it's a ghost. Okay, so it's working. So we're clicking the button, and it's doing that. So the question is, how did we hook it up again? What we did is we held down Control, the Control key, and we dragged from the button into our code. And when we let go, it asked us all the questions, what do you want to call it, that kind of stuff. All right, so we got this hooked up, right? Now we need to flip the card over when this happens instead of just saying ag a ghost, okay? So we're not going to say ag a ghost anymore. So to do that, I'm going to add my own function that flips the card over. So let's create our own Swift function. So we have to say func, because it's a method on a function. I'm going to call this flip card, okay? And I'm going to have two arguments. One is the emoji that I want to be on this card, right, the ghost or whatever. And the other one is the button that I want to set the emoji on or whatever. So interestingly here, I'm going to call these things strange, what you might think are strange names. I'm going to say with emoji, emoji of type string. So this is external name with emoji, internal name emoji. And how about this one? On button, UI button. Okay? Now, these might seem really strange to you as names of parameters, both internal and external. And in your reading assignment on the last page, it's going to link you to a document you have to read that explains how to pick good names here. Okay? Because there's a very well-defined set of rules for picking good names here. But the number one rule is when someone calls this function, it should read like English. That is the number one requirement of picking these names. So let's call this function in touch card right here because we want to call it with the ghost. So I'm going to say flip card. Okay, notice by the way, as I start to type, look at Xcode trying to help me. Xcode's so nice. You see, look, it knows that I have a flip card method. In fact, I'm just going to hit tab and it shows me the method with the argument names and I'm just ready to fill it in. So this is called, from the caller's point of view, flip card with emoji. The emoji is, let's say, for example, our ghost. I'll just copy and paste him from right here. On the button. And which button? Of course, the sender. That's this sender right here. So you see, when I call it, it reads like English. Flip the card with the emoji ghost on the sender button. Okay? That's our number one thing we're trying to accomplish. But inside here, we wouldn't want to be saying like, well, if the button title equals with emoji, that just is weird. Or you know, instead of sending a message to the button that says on dot whatever, that would make no sense. So that's why we have these different names. Now, it is possible and legal to only have one name, like just emoji. Then the external and internal name would both be emoji. Okay? And this underbar thing, like right here, that means there's no argument. In other words, it's like Java or some other language. Okay, we almost never do that. It is done. The document will tell you when you can do it. We almost never do it. It's here in this touch card because that's an iOS thing that's sending this message. It's from back in the Objective-C world. Objective-C doesn't have this internal external name thing, so that's why it's underbar there, okay? But we don't really use underbar that much. All right, so how are we going to implement this flip card right here? Well, this flip card is essentially going to toggle it, and I'm just going to have this flip card method look at the button. If it's already the ghost, then I'm going to have it flip it over to orange with no text. If it's not, then I'm going to put the ghost on it with white background. Okay? Just exactly what we played around with earlier. So we need to check to see if the button's current title is this ghost. So I'm just going to try and type this in. Let's see. If the button, okay, now I need to send a message to the button asking it, what's your current title? Okay, well, probably I want to go look in the documentation, figure out what button does. In fact, that's what you want to do. But there's actually a cool way if you just want to guess what it is. You can press dot. That's how you send a message in Swift, just like Java, right? Dot to send a message. And when you do that, Xcode is going to show you all the methods and variables that button understands. And let me say there are quite a few. Okay, I'm scrolling through here. I'm only down to the C's. Okay, we got D's. There's probably a couple hundred. Okay, so how does this help me? This doesn't help me at all. Well, the cool thing is, if I just type a word here that I think might be in the name of the method I want, like title, okay, I want to set the title. Now it just shows me things that start with title, or that have title in it, or have T-I-T-L-E in it, which is not very useful, but that's why I put those at the bottom. But anyway, we've got these titles, so now I can start looking around in a much shorter list here to see if I can find it. So here's title color, definitely don't want that. Title rectangle, no. Oh, here's set title. I don't want to set the title right now, but that's kind of good to know. Oh, look at this one, current title. Current title that is displayed on the button, victory. I found exactly what I want, okay? And when I find what I want here, it looks like, by the way, it returns a string, I think. Well, we'll try it anyway. If I double click on it, it's going to put that there for me. And now I can just say, is that equal to the emoji that you're asking me to flip the card to, right? This first argument. Notice how I'm using emoji and button as my internal names here. I'm not using with emoji or on. That was for the caller. Okay, so now I found out that the button already here has the ghost on it. So now I want to make it orange and blank. So now I need to set the button's title. And I saw before that it was set title. Okay, here it is, set title. Now, this set title has this extra thing here for UI control state. You see that? It's like, what the heck is that? I don't know anything about buttons, so I'm not sure. But I don't see any other set title, so I guess I'll have to go with this one. Okay, so I double click on it. The title I want to set here, of course, is empty string, because I'm trying to do the back of the card here, so I empty it out. And now I'm kind of at this control state impasse, because I don't really know what this means. So here's another cool thing you can do, is hold down Option, okay, and mouse over anything. You see how it's highlighting things with a little question mark right there? And you can click on it, and it'll show you the documentation for that thing. Okay, so here's set title, the documentation for it. And if I read through this, the third paragraph in the description says, at a minimum, you should set the value for the normal state. Okay, sounds good. Now, I'd like to understand how to get that normal state. So I'm going to actually click on this link here. You see UI control state, and it's going to take me to the documentation and show me control state. So here we go. Click, brings up the documentation. Here's control state. See that? And here it is, normal. The very first one is called normal. And we're going to see later how we use these things, but this is a static. You see it says static var, so it's kind of a property of the type. And so the way that we would type that in is to say UI control state dot normal. So that's awesome, we found that. But while I'm here in the documentation, let me briefly show you how the documentation works. Right here you can see that I'm looking in UIKit at its views and controls, at the class UI control, which button inherits from. And we're looking at this thing, UI control state. But I can click anywhere here and go back and maybe look at UI button if I want. And here's UI button. Now, when you're looking in the documentation, I super strongly recommend you read these overview sections. You see where this says overview? This overview section in each class is only take you 5 minutes to read, and it's really going to help you understand what the heck is going on here. Okay? So I strongly recommend you do that for all the common classes that you're using. UI button, later we're going to do array and dictionary. Go read it so you understand what the heck is going on in here. Okay? Got that? You can also search the documentation, of course, here. And in addition to overview, it has a list of all the methods. And here you can, for example, here's set title again. You can go back. This is the same that shows up in that little box. Okay? So now we know that this control state here is supposed to be UI control state dot normal. It's going to set the normal control state. We also want to set the background color. So I'm going to do button dot, and I'm going to just take a flyer, background color. Oh, sure enough, look. Background color. There's something exactly called background color that takes a UI color, I think. Let's double click that one. Okay, and I'm going to set that equal to. Believe it or not, you can actually put a color literal in here. You just do that by starting to type the word color, and you're going to see the first choice is always color literal. If you double click on that, it puts a little square in here. If you click on the square, you can pick the color you want. Okay, so let's go back and pick our nice orange, because that's what we do in the background. And so we've set our background color to orange. Okay, and it's really nice to be able to see that in your code. It really highlights the colors you're using. All right, otherwise, if it's doesn't have the ghost right now, then we want to put the ghost on there. So I'm going to do pretty much exactly the same code here. It's just that I'm going to set the title instead of blank, like the background. I'm going to set it to the emoji, the ghost in this case. And I'm going to double click on this orange square and change it to white, because I want a white background for the front. Everybody got that? Okay, let's run. See if our card should flip over now, which is getting us quite a long way along the path here to getting concentration working. Right here is our ghost. Cross your fingers. Woo! It flips over and back. Okay, excellent. All right, we're on a roll. Now let's go and add another card. Okay, we got one card. Let's go to a second card. Believe it or not, you can take things in Interface Builder that are the way you want and just copy and paste them. So now I have two cards. And this card already is the right shape that I want. It's got the right font size, all that stuff. So it's really recommended to copy and paste versus dragging out a new one and trying to set it to all the same things. Just copy and paste. Okay? Now, this one wants a different thing on it. So let's do something like, I think, pumpkin. Yeah. Well, we could do a pump. No, we'll do pumpkin. All right? So we got pumpkin. So we got a pumpkin card and we got a ghost card. Now this pumpkin card, it needs a method, so we're going to control drag to create another method. So if you missed it the first time, this is how we do it. It's an action. I'm going to call this touch second card. The type, of course, we want to be UI button, argument sender, connect it. Here it is. I'm going to take this exact same code from here, put it down here, but instead of the ghost right here, I'm going to use our pumpkin. Okay, looks good, right? This could not possibly go wrong. This is so simple. It's got to work. Okay, let's do it. All right, here we go. The ghost, still working like a charm. And the pumpkin, not working. Okay, what is wrong with our pumpkin? How could this pumpkin possibly not be right? Okay, well, we could get in the debugger here, set a breakpoint. It's real easy to set a breakpoint, by the way. You just click on a line number, puts a breakpoint there. But we're going to do a little more lightweight debugging. I'm just going to put a print here in flip card to see if this is even calling flip card. It should be calling flip card because it's connected here to this method, so it should be calling flip card. So I'm just going to go in here and say print that I'm in flip card with emoji. And now I want to put this emoji in here. Now, in a lot of other languages, you would probably say %s, comma, emoji, or something like that, right? This would be your, this would be your string, okay? But we don't have this %s business in Swift. We have something better, which is backslash, open parentheses, close parentheses. Okay, so backslash, open parentheses, close parentheses means put something inside there, it's going to interpret it as a string and embed it in this string. So that's exactly what we want. Emoji, and the cool thing about it is I could put, this is a string, so it's easy to embed, but I could put an int here, anything that can be converted to a string, which most things in Swift can, I can put there. I could even put an array there, or a dictionary. As long as the array only had things that could be converted to a string, then it can convert the whole array to a string. Okay, so this is a really cool feature, this backslash, open parentheses, close parentheses. All right, so let's run again and see if that pumpkin is calling flip card, which it should be. All right, so the ghost It's definitely calling it. See, flip card with emoji, the ghost. How about the pumpkin? Oh, it looks like it's calling it. But I didn't press that twice. What's going on there? That's kind of weird. Let's do it again. Oh no, look at that. It's doing both. Every time I press the pumpkin, it's doing the ghost and the pumpkin. Ghost and pumpkin. Why is it doing it twice? Okay, that's clearly messing things up badly. Well, let's look and see why it's doing that. We know that this method is being called by the pumpkin, and this method is being called by both. Okay, that's the problem. And why did that happen? Because I copied and pasted the ghost. And when I copied and pasted the ghost, it copied and pasted the fact that it was sending that message. So this is a common mistake to make, really easy. So I did it intentionally to show you how to get out of this, which is to right-click on something. If you right-click on anything in the UI, it will show you all the connections that it has. Okay, so this is the pumpkin. It's sending touch card and touch second card, but we only want to send touch second card. So I'm going to disconnect touch card by clicking right here. Okay, now I fixed it. Okay, now the pumpkin is sending this, and only the ghost is sending this. Okay, so right click is an important thing to know. If you ever get in a situation where it seems like, I thought I wired that up. Why is it not sending it? Or even why is it crashing trying to send something that I didn't intend? Right click on it will tell you why. So let's run, see if that indeed fixed our problem here. Imagine it will. Okay, it's got the ghost flipping over. We got the pumpkin flipping over. Okay, excellent, all going great. Now before I add yet more cards, I want to have some UI that tells me how many times I flipped cards. Because you notice in this game, the fewer times I flip it, the better I am at it, right? If I flipped them all over, up and down, then I'm not very good. It's easy, I didn't have to concentrate. So I want to have some UI that says how many times I've flipped a card, okay? So to do that, I'm going to start, let's get rid of this print in here, we don't need that debugging anymore. So I'm going to start by adding an instance variable to my class that keeps track of the flip count. Okay, real simple like. Move this down here so we get some space. All right, so what does it look like to add an instance variable to your class? Really simple. You use the keyword var, short for variable, then the name, flip count, then the type, :int. That's it. So I have added here a variable called flip count to my class, and I'm going to keep that flip count up to date as those cards are flipped on. But look what happened here. I had an error. So this red, when you have a red error, your app won't even compile and run. Okay? You can also get a yellow one. Then your app will compile and run, but do not submit your homework with yellow ones either. Even though they're just warnings, they're usually indicators of something bad. So don't do that either. But this red, I got to fix this red. Now what's funny is this red came up on a different line of code. Okay, I typed this line of code in, and it came up on a completely different line. Well, what does it say here? It says, class view controller has no initializers. Why is it saying that? What does that have to do with it? Well, this is happening because Swift requires all instance variables, which by the way in Swift we call instance variables properties. So when you hear me saying property, I mean instance variable, okay? So all instance variables, all properties, have to be initialized. You are not allowed to have them like this, flip count int. What is the value right now? It has no value, okay? It has to have an initial value. It's just not allowed to be sitting out there, okay? Now there's two ways to initialize an instance variable. One is using an initializer. So that's what this error is trying to tell us. Go get an initializer here, dude. An initializer is just a method with a special name, init, short for initializer, and it can have any arguments you want. In fact, you can have multiple inits, each with different arguments, but each init is responsible for initializing all of the variables. Okay? That's what the init's job is. So we could add an initializer here and do that. Now, unfortunately, adding an initializer to a class can be kind of complicated because of inheritance, right? Because your superclass has initializers. You've got to make sure they get called properly. So I'm not even going to talk about initializers yet. Okay, I'll talk a little bit about them on Wednesday. Next week we'll really talk more depth about initializers. And so what's the second way that I can initialize this, since I don't want to do initializers right now? And that's just right here to say equals 0. Okay, if I just why are we pressing V there? Okay, equals 0. Okay. That initializes this. That's going to cause this error to go away. All is well. And this is how we initialize most of our instance variables. Now, while I'm here talking about instance variables, I want to talk a little bit about Swift and typing. Okay? Swift is an extremely strongly typed language. I mean extreme. Okay? It does have a type which is kind of like untyped, but really it's mostly for backwards compatibility with Objective-C. In most cases, you want to be very specific about what types you're using. And some people complain about strongly typed languages. Oh, it's so much burden to always be typing something. Okay, well, Swift is also a language that has strong type inference, which means it will, if it can, guess the type for you. Okay? So in this case, you see I have this :int type. That is completely unnecessary in Swift. And not only unnecessary, we would not put it in there. There's no reason to put that there. Why is that? Because this 0 is clearly an int. Okay? Swift treats all literals like this that don't have any decimal points as ints. And so this is an int. And how do we know that? If we hold down Option, just like we did when we clicked on title down here to get the documentation, we can click on flip count. And it'll say flip count is an int. You see that? And if I had said flip count was 0.0, then if I hold down Option and go back here to flip count, it says flip count is a double. Okay? So it infers it. If I said flip count equals, quote, hello, it's going to say, okay, flip count is a string. All right? So it's going to infer. Now, this is easy to infer because this is a constant, but Swift can even infer in the most amazing, complicated situations. If there's only one type that thing can be, it'll make it that type, and you don't have to put the type. So it's surprising in Swift, the time you put types in the most is arguments to functions. Okay? Because that, you kind of have to say what you're expecting there. But otherwise, you rarely are actually putting the types. It's quite amazing, actually. All right, so we have this flip count here. Let's go ahead and increment it. Okay, every time someone presses on a card, I'm going to say flip count plus equals 1. And ugh, I'm going to copy and paste the code. Oh, God. Anytime you're copying and pasting code, you're doing it wrong. Okay, that just can't be right. Okay, so I just did something that's not right, but I'm doing it anyway. I could probably put that somewhere else, but I'm going to just do it this way for now. You'll see why in a second, and we'll fix it. But we don't want to copy and paste code. But each time a card is touched, I'm going to increment the flip count. Now, that's great, but I need this flip count to appear in the UI. Okay, I want the user to see how many flips they've made. So I have to have this int appear in the UI. So how do I do that? Well, I need some sort of other UI element besides a button, and that's just a little text field. Okay, in fact, it's a read-only text field, which is called a UI label in iOS. And so, of course, anytime I want to add something to UI, I go here to the bottom side. In fact, right next to button here is label. I'll drag it out and put it in here. I'll try and center it or something like that. It's really, really small, so I'm going to make it much bigger because I'm going to use a big font in a second here. Even make it taller. The text is black, so it's black on black. That's a little hard to see, so I'm going to go back over to here, go to the top half here, change the color of the text, okay, which is a label property right here, from this to our favorite color, orange. This text is really small, so I'm going to change the font from 17 point, which is the default here, to something like 40, much better. I don't want it to say label here. I want it to say flips. Let's say we'll start out flips 0. I don't want it left aligned like that. Okay, I don't want the text left aligned. I want it in the center, so I'll go over here and hit center. So see how I'm just using this editing inspecting up here to kind of get the thing to look the way I want it to look. I can even use my dash blue lines here to put it right along the bottom and right in the center. Okay, even though I said we're not really using those, it's still useful to do that with. All right, so now I have my UI. How do I talk to it? How do I tell it when the flips change to show the flips? Well, I'm going to do that also by making connection between my UI and my code, and we know how to do that. Control, drag, right? Control, drag, put it right here. And this time, though, I'm not doing an action, I'm doing an outlet. And what an outlet does is it creates an instance variable. Okay? So action creates a method, outlet creates an instance variable or property. And that property is going to point to this UI label, and I'll be able to talk to it and tell it to update itself when the flips change. All right? So what am I going to call the name of this thing? I'll call this my flip count label. It got the type right here. It didn't say any. Don't worry about this storage weak. I'm going to talk about that next week. And so I'm going to hit connect, and it's going to create another var, like var flip count, but this var is going to be a little different. This var is, sorry, wrong place there. This var is var flip count label, which is type UI label, okay? Now, it can't infer this type, by the way, because that UI label is in the UI. So Swift doesn't know how to look in a UI and infer a label, so it can't infer that there. So we do need to explicitly say it's a UI label here. Week, I told you to look next, we'll tell you next week. This is another kind of directive like this one that puts the little dot there so that we can see that's that, that's that, that's that, okay? So here's the var, exactly the same as we did with flip count. Notice there's a little exclamation point there. That is super important, but I'm not going to talk about it today, okay? I can't talk about everything all at once. Notice that this very important thing also has a side effect. It's not the primary purpose of it, but the side effect is it doesn't have to be initialized. Notice this doesn't say equals anything, and yet we don't have an error. Okay, so don't freak out about that. I'm going to talk all about this exclamation point. It could not be more important. It's probably the most important newish thing that you're going to learn about Swift, okay, is what this is all about. All right, so I got this flip count label right here. Now all I want to do is every time this flip count changes, like right here, I'm going to talk to the flip count label, and I want to set its text, label. I want to set its text, so I'm going to send it a message, and I want to set text, so I'm just going to say text. Oh, there happens to be something called text, the very first one there. You see that? It says text as a string, so I'm going to double click on that. All right, and I'm going to set that text to, flips, colon, and then I'm going to use my favorite feature right here, backslash, open parentheses, close parentheses. I'm going to put the flip count in there. Okay, so that's going to change the text on this flip count label here to say flips colon 1, flips colon 2, whatever. And of course, I have to copy and paste again, arg, right there, because I need to update it each time. So let's see if this works. Okay, here we go. Let's try flipping this card. Ooh, yeah. Every time we flip over or back, it's incrementing the flip count. Okay, fantastic. Except for this really is nasty having this copied and pasted. I mean, imagine I really was doing it this way, and I had another button called New Game, and I had to set the flip count back to 0. I'm going to have to put this same line of code there, too. And what if I someday said, well, I don't want this to say flips, I want it to say flip count. Then I got to change it all 3 places. This is just horrendous coding. Luckily in Swift, there's a way to totally avoid doing this in this case, which is that any property, if you want, you can put code after it that says did set, and it will execute this code every time that thing gets set. Okay? This is called a property observer because this code is observing changes of this. So we can take this out of here, put it up here, and we can take it away from here now. Every time flip count changes, it's going to execute that did set and talk to the label and update it. So now if I add a new game and said flip count equals 0, it would automatically update. See that? Okay, so property observers, really cool. Obviously, we use property observers a lot to keep the UI in sync with the instance variables of our class. Okay, so you'll see that happening all the time. All right, time to get more buttons, okay? We got these 2 buttons. By the way, notice that we're driving our UI from the code, right? It's this line of code that's saying what's on the UI. So I'm actually going to change these 2 buttons to be face down, okay, when they start. And what's interesting is if I select them both and go over to the top here of this thing, notice it notices they're both buttons. So I can change things, like here it says multiple values for the text, ghost and the pumpkin. I can set that to blank, and I can go down to the bottom to set the background color here to orange. And it's affecting both of them. So if you select multiple things, as long as they're of the same, they share the same type, then you can edit them all simultaneously. Okay, so I have these cards. Let's make some more cards. I'm going to copy and paste these cards. Actually, before I do that, let's do one other thing. I'm pretty unhappy with my architecture here, because if I want to add more cards, I guess I'm going to have to do copy touch third card, fourth card, fifth card, sixth card, seventh card, eighth card, okay, that is going to be the worst code. You would get an F on your homework if you did that, okay? That's just awful. So we're clearly not going to use that architecture to do that. And in fact, I want to get rid of this touch second card entirely. And I just want to put everything in touch card. And that means I won't have this line of code duplicated and this line of code duplicated. This is going to be great. This is a much better UI. So to do this, I'm going to right-click on this one and disconnect touch second card. And instead, have this guy control drag to here. Look at that. You can hook it up to one that already exists by just dragging to it and letting go. So now, both of these are sending touch card. Okay? So that's great. But inside here, we obviously can't do this, have this ghost thing here, because then it would set both cards to ghost. So how are we going to have code in here in touch card that works for all the cards? Well, what I'm going to do is I'm going to create an array of all these cards. And when touch card is pressed, I'm going to look in that array, find the button that's being pressed, and then I'll know which card it is. Then, when I know which card it is, which index it is in the array, I'm going to look up in another array the emoji to put there. So it's going to be data-driven, right? And so if I want to add more cards, I just add more cards to my emoji array. It's going to be great. All right, so let's make more cards. I'm going to copy and paste to make more cards. So now I have 4 cards. And now I want to make an array that includes these cards. Okay, so how do I do an array that includes these cards? Well, that's a connection between the UI and the code. So I'm going to control, drag, and create another var right here. Okay? But this one's going to be the third kind, which is outlet collection. So an outlet collection means an array of the things in the UI. So I'll call this my card boot. I'm actually going to make a mistake, okay, and say card boutons instead of buttons. Okay, boutons, because I want to show you how to fix this mistake if you do. And it's got the type right. This is going to be an array of UI button. Okay, so I'm going to connect it right here, and it created another var for me right here, this one. And look at its type. See that right there? That is special syntax in Swift that means an array of UI button. This might look more familiar if I use another Swift syntax, array of UI button. Does that look familiar to you from Java, right? So array is a generic class. Everyone know about generics in Java, hopefully. It means that you can't have the class array on its own be a type in Swift, because I told you Swift is very strict about types. So when you were putting things in and out of that array, Swift would have a heart attack if it didn't know the type of thing you're putting in there. So when you create an array, you have to specify what type of thing is in the array so that Swift can breathe easy, okay? Now, arrays are so common that instead of using this normal Swift, this is normal Swift syntax right here, but for arrays, we do this special thing here where we say open square bracket, UI button, close square bracket. It's just for arrays that we do this. Dictionaries also have a special one. I'll show you that on Wednesday. Okay, so that's an array. Card buttons is array. Now, I have this card boutons here, okay, and this is connected to that one card. I haven't put the other cards in there yet, but I will. It's connected to. Now, what if I decided, oh no, I don't want boutons. I made a mistake. It's buttons. And remember, I told you, you don't want to edit things in here that are also in the UI. Okay, like the name of the class and things like that. Well, if you do that, look what happened to the little circle. Okay, it doesn't have a dot in it anymore because it's not connected anymore. Because this, if I right-click on it, it's connected to card boutons there. Okay, it's not connected to card buttons. So how can I fix this? If I said this card boutons, okay, it's back to being connected now, and I want to change this. It's another magic key, the command key. Okay, we already showed you the alt key for getting into the documentation. If you command click on something, okay, like this card boutons right here, you get another kind of menu here that'll do some cool things like jump to the definition of this thing, which happens to be right here, so that's not going to go anywhere. Show the help, just like the option one does, and also rename. And when I click rename here, look what happens. The UI kind of churns a little bit, and it looks through my entire project and finds that card boutons everywhere, including in my storyboard. See that? So now, if I change this to card buttons, here, it changes it everywhere. And now, this is not broken. And if I right-click on this, it's card buttons. Okay? So command click rename. That's how you want to rename things that touch both your UI and your code. All right, so I got this card buttons here. Now I need to somehow in touch card, okay, I need to look into my card buttons array and find that button, okay? By the way, before we do that, let me put the rest of these cards in there, okay? I'm going to show you another way to connect up your UI to your code. It's this yellow button right here. You see this yellow button at the top? It says View Controller. This button also represents your code. So if you want to control drag from here, you can do that as well and hook up to card buttons. Control drag from here, card buttons. And I'm intentionally not going to hook up this card because I want to show you what happens when we don't hook up a card. So look at card buttons. It's got those 3 cards and not this one, right? All right, so how am I going to look in card buttons and find it? Well, of course, Swift Array is a fantastic class. It's got so much great functionality. And one thing it knows how to do is look inside and tell you what the index is of something inside of it. And that method is called index of. All right, so let's just call that method. I'm going to create a var called card number, which I want to be the number of the card, 0, 1, 2, 3, 4, wherever it is in the array. I'm going to set that equal to card buttons dot, right, sending a message card button, index. Now, interesting, look how many methods are called index in array. Multiple methods, okay? In Swift, that's perfectly legal. Swift, you can have 100 methods all with the same index, but they all have to have different arguments. You see how all these index methods have different arguments, right? Get the index after something, the index before something, whatever. I want this one down here, the index of something, which returns a int. Okay, that's going to be a problem, that int. We're going to see in a second here. But if I double click that, I've got the index here. So I want to find the index of the sender because I'm in touch card right here, so the sender. And I'm just going to print this out. So I'm going to say card number equals, and we'll do our magic thing here, and we will just print out the card number. Okay? So before we go look it up in an array and find the emotion, let's just make sure that we're finding the right card right here. Now, right away I get 2 warnings here. Let's go look at these warnings in depth. Let's make our whole screen show these warnings. The first one is variable card number was never mutated. Consider changing to let constant. What does that mean? Well, indeed, card number, we give it an initial value here of looking up the card in the card buttons array, but we never change it again. So it is not in fact variable. It's a constant. Okay? And in Swift, we always mark constants as constants. But we don't use const, like in C and other languages. We use let, L-E-T. And here's another cool thing. You see this little triangle? If I click on it, oftentimes, Swift will fix it for me. See that where it says fix? It's saying, you want me to replace var with let? Like, yeah, sure. And it did. See? Now, why do we use let instead of const? Because we want Swift to read like English. Let card number equal card buttons index of the sender. Woo! Sounds like English to me, ish. Okay? So that's better than const card number equals. Okay? So you're going to get used to using let. Always use let when something's a constant. Never use var. All right? This other warning right here, I'm going to ignore. Okay? And let's just see what happens here when we run. So let's run this guy on our simulator. We're ignoring that. Pay no attention to the yellow warning there. Okay, here it is. Let's click some of these buttons and see what happens. See, you know, it's going to print. We'll put this over on the side so you can see the code at the same time. Okay, we're just going to print out the card number that we found by looking that index up. Ready? Click. Huh. That's kind of weird. Look at that. Optional 1, optional 2. What's that optional about there? It seems to be seeing the card right, 0, 1, 2, but it's saying optional. Why is it saying optional? Well, this is that super important thing I was telling you about. Here it is. Okay? Let's option click on index right here and go look at its documentation. And the return value of index is not an int. The return value of index is an optional. That's what that question mark means. We've seen question marks all over in the documentation, right? It means optional. And optional is a different type entirely from int. Okay, it has nothing to do with int. Optional is a type that has 2 and only 2 states, set and not set. Okay, it's an enumeration. Okay, you've probably seen enumerations in other languages. Enumerations are things that have discrete set of values. This one only has 2 values, set and not set. That's it. But the cool thing about enumerations in Swift, not a lot of other languages have this, for each case of an enumeration, you can have associated data. just data that goes along with that thing. Well, an optional, when it's in the set state, has associated data, which in this case is an int. So this index method is returning whether or not it could find that button in there by returning set or not set. And if it does find it, it also gives you the associated data of the int. That's what you're seeing down here. It's printing out, when we print card number, it says this is an optional, it's in the set case, and the associated value is an int. Got that? Now what if we click on the button that's not in the card buttons array? Let's see what that prints, that does right here. Whoops, we stopped. Let's go back and run it again. I'm going to click on that fourth button that isn't in card button. So when index looks it up, it's not going to find it. It's going to return not set. Let's see what that looks like. Click, nil, N-I-L. So in Swift, the word nil means the not set case of an optional. That's the only thing it means. In other languages, it means 0, pointer, and other things. No, in Swift, it always means an optional that's not set. Okay? You got that? All right, so that's no good to me, though, to have an optional. I can't look that optional up in another array of emoji. I need the int. So how do I get that associated value if it's in the set state? Well, one way is to put an exclamation point at the end of it. If you put an exclamation point at the end of an optional, it says, assume this optional is set, and grab the associated value. Okay, so let's see what that looks like. You're going to see this optional syntax is all really simple. Question mark, exclamation point, 1 characters, because it's so common to do these optionals. All right, so here, look, card number 0, 1, 2. Excellent, it's working. What do you think happens if I press this one right here? Crash, exactly. Why is it going to crash? Because you're returning an optional that's not in the set state, so it doesn't have that associated value, so it crashes your program. And you're going to see this crash quite a bit, okay, when you're developing, because you'll just accidentally do this quite a bit of times. And if you look in your console, look what it says. It says an error here, fatal error, unexpectedly found nil, that is to say not set, while unwrapping an optional. Okay, get used to that error. You're going to see it all the time. Now, this might make you say, whoa, I'm never using exclamation points. It's going to crash my program. Oh, scary. Yeah, it's scary, but crashing your program can be really good because it makes you find problems. Like in this case, that fourth button is supposed to be in card buttons. It's a bug that it's not in card buttons. And if I didn't crash right there, I might not find that bug because I might not have clicked on that one. I might not have noticed. This way, I'm for sure going to find it's going to crash. And not only is it going to crash, it's going to crash right where it matters, right in the debugger, so I can look at it. So don't be afraid of crashes. Okay, crashes can be good. But let's say you wanted to do this code in a way that didn't crash, that kind of conditionally looked to see if it was in the set state, and if it was, then use it. Otherwise, didn't do it. Okay, to do that, instead of putting exclamation point at the end, you take that off and put if at the beginning. Okay? And so now, if this optional right here is in the set state, then this code will execute. Otherwise, it won't, and it won't crash. Okay? So that's if, that's conditional. You can see, again, optional, minimum possible syntax here. So now we can put this print card number inside here. We could even, if we wanted to, put an else, something like chosen card was not in card buttons or something like that, so we could notice that it happened. Okay, and here we're conditionally doing it. So let's go look at this. I'm going to make this console wide here so you can see what's going on. All right, so here, this is still working, card number 012, because I'm using that if let right there. But now if I click on this bad button, it just says chosen card was not in card buttons, right? It says this. Okay, so that's optionals, how to unwrap them. Super duper important. Really going to have to master this. I know that's new to you. We're going to talk about these exclamation points up here that I mentioned before that made it so you didn't have to initialize these things. Those are optionals as well. They're a little different kind of optional because they're exclamation point instead of question marks. Okay, remember this index one right here? Okay, that was a question mark one. These are exclamation point ones. They're slightly different optionals, but they're still optionals. We'll talk about that later. So the last thing I want to do here is just take this card number that I got and go look it up in an array of emojis. So I'm just going to make a var. I'm going to call it emoji choices. It's going to be an array of string, emoji strings basically. And you can create arrays right on the fly by doing open square bracket and just putting the things in the array. So I'm going to go put my emoji in here. Let's go back to our little emoji chooser. Probably it's infrequently used. Yeah, here we go. There's the, we'll put a pumpkin there, we'll put a pumpkin there, we'll put a ghost here, put a ghost over here. All right. Now we've got that, so we're going to look, the card number is going to be index 0123. We're going to look it up in here. While we're here, let's go ahead and wire up that last wayward button that's not in the card buttons array. I'm going to do that again from up here, Control drag down here to put all 4 buttons in there. Go back to automatic here. And one other thing I'm going to do is note that this, is that necessary? No, because it's clear that this is an array of strings. So if I option click on this, on emoji choices right here, it says array of string. So that, again, the inferring. We would never put that colon array string there. Never. Okay, totally unnecessary. Okay, so now instead of just printing the card number out right here, I'm going to call my flip card with emoji, and the emoji is going to be emoji choices sub card number. Okay, and it's on the sender. Got it? Let's run it. Okay, here we go. Pumpkin, ghost, all of these things are working. Okay? Now, we might be very proud of ourselves here because we got this data-driven architecture. It's really great. We can add more buttons now. We can make 20 buttons, and all we got to do is add more things to this array. But this is actually not a very good architecture because this is very fragile. Okay? The number of emoji here has to exactly match the number of buttons in the UI, and you have to put them in there exactly twice, and they're not in random order, so the cards are always going to be in the same place. Kind of not a very good solution. So we really need to take another step and have a real concentration engine driving our app that's doing not only all this, but all this matching and all that stuff. Now to do that, we're going to use this design paradigm I talked about at the very beginning, Model View Controller. So I'm going to start Wednesday's lecture with some slides explaining how Model View Controller works. Then we're going to apply Model View Controller here, and you're going to see, whoa, that is a way better way to do this. It's much more flexible and extensible, easy to add cards, not going to crash, everything. Okay? So I'll see you on Wednesday.
For more, please visit us at stanford.edu.